Hi, in this video I'm going to solve the first example of linear approximation. My goal here is to estimate the square root of 9.2, letting be the f of x to be the square root of x, and I have here on the right in blue the formula we'll be using to solve these problems. So let's start by saying the closest known value for this square root of 9.2, of course, has to be, well, something has to be the square root of 9. So it would be the square root of 9 will be equal to 3. So it has to be the result for this 9.2 has to be slightly above 3. I have here on the left this graph that depicts the square root of x. Of course, I'm doing like a super zoom in to get really close to these values. Here, the difference between 9 and 9.2 would be the delta x. And here, delta x, in terms of the derivative, would be here the x. We know delta x it's equal to dx. However, this is the delta y. The delta y, it's not exactly the same as the dy. dy and delta x, delta y, are really close as long as we get really close to this value. If we're really close in terms of this graph just we're showing, we can conclude that dy will be approximately the same as delta y, and vice versa. So the thing is, let's use this information in order to work this through and use the information we have. So let's see, dy in this case will be equal to f prime of, in this case, I'm going to use yellow, f prime of 9 times the dx. I'm going to be using green for the dx. So with this, we can find this piece of this formula, and we can find as well this piece of dx. Well, now let's get them. So if we know that f of x is equal to the square root of x, well, it's f prime of x will be equal to 1 over 2 times the square root of x. So f prime of 9 will be equal to 1 over 2 times the square root of 9, which is in both would be f prime of 9 would be equal to 1 over 6. So that's the f prime of 9. We already found this piece of the formula. So let's get to now the dx piece. So dx is roughly, just remember, the same as delta x. Now delta x, we can find it out, would be the final value, which is in this case 9.2 minus the initial one would be 9. So dx, in other words, would be 0.2. That will be it. Now let's fill in the blanks here for the formula. Dy will be equal to f prime of 9, which we know it's equal to 1 over 6, be times the dx, and we just found it's 0.2. Now let's work this through. Dy it's equal to 1 over 6 times, now this 0.2 is just the same as saying 2 over 10. If you divide 2 over 10, you will get in return this 0.2. Now we can simplify these things. This would be half of 2 will be 1, half of 6 will be 3. So we get that dy it's equal to 1 over 30. Now this dy, as we can see here on the graph from the left, this dy is something really close to the delta y. But what we're actually looking for is this f of 9.2. Now this dy, it's only telling us this height. In order to get to this height, which is f of 9.2, we must add something else. We must add this height. Now this height represented in terms of the graph, this height, I'm going to sign it here on the left, it's actually the value of f of 9, which we know it's in here. So let's get to this approximation. I'm going to use a different color. I'm going to be using orange. So we could say that f of 9.2 would be approximately f of 9 plus dy. Now we know all these pieces, so we just have to write them down. Here will be f of 9.2 will be approximately f of 9, which is we know it's 3, plus the dy that we know it's 1 over 30. And with that we are let's see, this would be, I'm going to write it like this, would be equal to 3 and 1/30. So with this we are done with this example. Feel free to rewatch it again. Well, that would be it for this one.